Challenge, and the challenge we're doing today is going to be called Mini RSA. It says, what happens if you have small exponents? There's a twist though. We padded the plain text so that m to the power of e is just barely larger than n. That's the crypto cipher. So if we look at the cipher right away, I was already messing around with it. Now you have my notes right here. So we have n equals to this value, e equals to that value, c equals to this value. So we have the ciphertext, our e value, and our n value. So if we look up how to decrypt this is the formula used to decrypt an RSA cipher, and we are missing D as it's stated right here. So how do we solve this challenge? So if you look up, if you have a small exponent, because that's the hint they gave us, so small exponent RSA attack, and then you can do e equals 3 because that's our e value. So it says, because the small exponent, e is our exponent. So with a small exponent like e equals 3, it's vulnerable to attacks, especially cube root attacks. So what is the cube root attack? So if the message m is sufficiently small, specifically if m to the power 3 is less than n, the cipher is equal to m to the 3 mod n. This can be decrypted by simply taking the cube root of c over integers. So if we look right away, that's what I have noted right here. But in our case, as it's stated in the problem, m to the power of e is just barely larger than n. So we have an issue. This can't be true, or could it? So if we look carefully, to do the cube root attack, c has to equal m to the power of 3 mod n. So basically, if you look at modular congruence or modular arithmetic, we could see that with modular congruence, there's a formula right here, a equals kn plus b. So if we look right here, this is very similar to the situation we have where c is equal to a, m3 is equal to b, because this could be any value, this could be any value, mod of n and mod of n. So this states, this formula, modular arithmetic or congruence, it states a is equal to kn plus b, where b is our n value. So b could be left alone, it could be whatever, but now any k value times n is equal to our a, which is basically our ciphertext. So now if I rewrite this right here, c is a, kn, it could be whatever value, m to the 3. But we want to be able to figure out is basically m to the 3. So if we basically let's see, if we subtract m to the power of 3 is equal to kn minus c so it'll be m, so it's gonna be c minus kn is equal to m to the power of 3, but k could be anything it wants to be, so the negative part of it is not gonna matter, and it's basically m to the 3 is equal to kn plus 3. So now we have this right here. So basically, to solve m to the 3, we basically, all we need to do is just find a k value that is basically the perfect cube root. So c we already have, like I said right here, and we already have. So to find the k values, it needs to be a perfect cube root. So basically brute force m3 by trying 0 to 1000 for k until we get a cube root for it. So how do we do this? So you could basically write code, and that's what I did in my case. So we're just gonna write the code for it. So if we look at nano, solve pi, and now we're just basically gonna copy the values that we already have in place right there. And now if we go right here, we're gonna be using a third library. So we're gonna go and we're gonna be using import GMPY2. GMPY2, if you guys aren't familiar with that library, it is basically an arithmetic library by Python. Arithmetic. It's basically for precision arithmetic. It's probably like, I guess, very precise. So we already have a value. So what we want to be able to is basically brute force our solution. So for every I in range of a very large number, in our case we're going to use 1,000. It could be larger than that, but we're going to assume it's 1,000. We want our value, our m value, and then we're going to look, is true root or is root, because we're going to be using the library, but we're going to be using the iRoot function, which is basically going to find the whatever root we pass it through is going to find it. In our case, our formula, we want it to try every I value times n plus c, and then after that we want to put it to the power of 3 or do the cube root. And now if we find the root, we want to be able to print out our m value as well as printing out the flag. But printing out the flag is going to be a bit different, because this is basically going to print out our integer value. But when it comes to RSA, we first want to be able to go from int to bytes, and then finally to from int to bytes and to text. So how we do that is basically, since we know our value is gonna print out on this is gonna be I, because we want to know what number is our k, and then we want to do m, which is basically our int value. So now we want to turn it to bytes, so we're gonna use our formatting to format it so it could be like bytes. So format it so it could turn into bytes, and then we're gonna do dot decode it to text, but not until we complete the formatting right here. Format, and then we're gonna, since that's gonna format it to hex, we're gonna do from a hex, and then we're gonna do dot byte array. And then we're going to do format, and then dot into this value, and then it's going to be our flag. And then if we control X that, and then Python 3 solve, we might not get a perfect one. Yeah, it was never close. So nano byte print flag. It was not closed. Oh, so we just close it or what? Close it right here. Hopefully we get it in one shot. Print flag. I times n plus c. So Python 3. So nano. If m is root is equal to I root I times n plus c e for every I in range of 1,000. Oh boy. Okay, so that means it didn't find in the first 1,000. So what if we go even bigger than that? And we try it again. And we did it. It was at 3,533, and our flag is PicoCTF. It should have been larger. So that's how we were able to solve this challenge. So yeah. So it takes a little bit of math to, I guess, solve this challenge. So that's why a lot of people don't do it, but it's pretty fun. But yeah, that's about it. Hope you guys learned something new today, and I guess I'll try out the flag and see if it gets it. And it got it. So yeah. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.